Morning to all of you. Today I am starting the topic of formal charge. Formal charge Fc, also represented by Cf. The formal charge on an atom is calculated Cf on an atom. This is equal to number of valence electron minus number of unshared electron minus 1/2 into total number of shared electron by that atom in the formation of covalent bond. This formal charge indicates the net charge present on the molecule or the ion. That is, sum of the formal charges of all the atoms present in the molecule ion or ion is equal to the net charge present on that molecule or ion. Now, what is the utility of this formal charge? The utility of the formal charge is that very important utility. It helps in deciding the correct Lewis dot structure for the molecule or ion. So this Cf helps in deciding correct Lewis dot structure of the molecule or ion. The correct Lewis dot structure or the more appropriate Lewis dot structure for a molecule or ion will be that for which the formal charge on the atoms is equal to 0. Cf is equal to 0 indicates the correct Lewis dot structure. Lewis dot structure for the molecule or ion. Therefore, in order to calculate the formal charge, first of all, we shall write the Lewis dot structure for that molecule or ion, and then we shall calculate the Cf on each atom by the equation number of valence electron in that atom minus number of shared electrons minus 1/2 into total number of shared electrons. And out of the various structures, Lewis dot structures, the structure for which the formal charge on the atom is equal to 0 will be the correct Lewis dot structure for the molecule or ion. Let us take few examples for that. Suppose it is your methyl alcohol. Methyl alcohol, which has the molecular formula or which has the chemical composition CH3OH. For this, you have to find out that which will be the correct Lewis dot structure for the molecule or the ion. And in order to find the correct Lewis dot structure, you will have to calculate this formal charge on each atom in each structure. And for that, you will have to first draw the Lewis dot structure. And in order to draw the Lewis dot structure, first you calculate the total number of valence electron X. This is equal to 1 into 4 plus for carbon, plus there are 4 hydrogen atoms, 4 into 1 plus 1 into 6. This will be equal to 4 plus 4 plus 6. This is equal to 14. Then we shall calculate the number of electrons required in attaining nearest inert gas configuration. Nearest inert gas configuration, that is Y. 1 into 8 for carbon, there are 4 hydrogen atoms, and the nearest inert gas for hydrogen is helium, which has 2 electrons in its valence shell. Therefore, this will be your 4 into 2 plus 1 into 8. This will be equal to 8 plus 8 plus 8. This is equal to 24. Now, number of shared electrons. Number of shared electron S. This is equal to Y minus X. This will be equal to 24 minus 4 minus 14. This is equal to 10. Number of unshared electron. This will be equal to X minus S. This is equal to 14 minus 10 is equal to 4. Now let us draw the Lewis dot structure. So one Lewis dot structure may be this. Two electrons, two electrons, two electrons, two electrons, two electrons. Total number of shared electrons are 10. 2, 4, 6, 8, 10. This hydrogen has completed its doctorate. This hydrogen has completed its doctorate. This also, and 4 lone pair of electrons are left. So this will be on more electronegative oxygen atom. So this is your 8 electron. Let the various hydrogen atoms are represented by CH, H, H, O, H. Let it is HA, HB, HC, and HD. This is the first Lewis dot structure. Now, another possible Lewis dot structure for this can be C, H, H, O, H, H. So this will be your 2 electron, 2, 2, 2, 2, 2, 4, 6, 8, 10. Four unshared, 2 unshared will be here, 2 unshared will be here for completing octet of carbon atom and oxygen atom respectively. So another Lewis dot structure for this methyl alcohol will be H, O, H. One lone pair here, one lone pair here. Suppose it is HA, HB, HC, and HD. This is the second Lewis dot structure. Now, in order to decide that which Lewis dot structure for methyl alcohol is correct, this first one or the second one, we shall calculate CF. that is the formal charge on each atom in this structure as well as in this structure. This structure for which the CF for all the atoms is equal to 0, that will be the correct structure for the methyl alcohol molecule. So let us calculate formal charge. In structure first, CF on carbon, this is equal to number of valence electron in carbon. Number of valence electron in carbon is 4 minus total number of shared electrons by carbon. Carbon is forming 4 bonds. So the total number of shared electrons are 2, 4, 6, 8 minus total number of unshared electrons. Total number of shared electrons for total number of unshared electrons. Total number of unshared electrons 0 minus total number of shared electrons 2, 4, 6, 8. 1 by 2 into 8. This total is equal to 0. This 4 represents the valence electron, 0 represents the unshared electron, and 8 represents the shared electron. Now CF on HA, that is on this hydrogen atom. This is equal to valence electron is 1 minus unshared electron 0 minus total number of shared electrons 1 by 2 into 2. This is equal to 0. CF on HB, second hydrogen atom. Again 1 minus unshared 0 minus 1 by 2 into 2. This is also equal to 0. CF on HC. This is also equal to 1 minus 0 minus 1 by 2 into 2 is equal to 0. And CF on HD. This is equal to 1 minus 0 minus 1 by 2 into 2 is equal to 0. So we find that for structure first, CF, that is the formal charge on all the carbon and hydrogen are 0. Now let us calculate the formal charge on oxygen atom. CF on oxygen atom. CF on oxygen. Valence electron for oxygen is 6 minus unshared electron 2 to 4 minus shared electron 2 and 4. This is equal to 1 by 2 into 4. This will also be equal to 0. So formal charge on all the carbon, hydrogen and oxygen atom in structure first is 0. In structure second, formal charge on oxygen, carbon, CF on carbon. This will be equal to, this is your carbon, valence electron 4 minus unshared electrons 2 minus 1 by 2 into shared electron. Carbon is forming 1, 2, 3 covalent bond. So this will be equal to 6. This is equal to 4 minus 2, 2. And this will be equal to 3 to 5 minus 1. Formal charge on HA, this is equal to 1. This is your HA. 1 minus 0 minus 1 by 2 into 2. This is equal to 0. CF on HB. This is also equal to 1 minus 0, 1 minus 1 by 2 into 2 is equal to 0. CF on HC. This is equal to 1 minus 0 minus 1 by 2 into 2 is equal to 0. CF on HD. This is also equal to 1 minus 0 minus 1 by 2 into 2 is equal to 0. Now formal charge on oxygen atom. This is your oxygen. Valence electron 6, unshared electron 2, and it is forming two covalent bond. So this will be minus 1 by 2 into 4. It is forming 3 covalent bonds. So 1 minus 1 by 6. So this will be equal to plus 1. So total formal charge, total CF, this is equal to minus 1 plus 0 plus 0 plus 0 plus 0 plus 1. So all the total, although the total charge on CF in both the cases is 0, that is, it is indicating that it is a neutral molecule. But in case of a structure first, we find that the formal charge on all the atoms is equal to 0. Therefore, structure first will be the correct structure for methyl alcohol molecule. Therefore, we can conclude that since CF for all the atoms in structure C H H H OH is 0. Therefore, C H H H OH is correct Lewis dot structure. Lewis dot structure for methanol. Let us take another example, and for that we shall find the formal charge on the different structures, on the basis of which we shall decide that what will be the correct Lewis dot structure for that molecule. So let us take another example. Suppose it is CoCl2, carbonyl chloride. In order to find the formal charge, we should first write the Lewis dot structure, and for that we should do these calculations. So first writing Lewis dot structure. Lewis dot structure. For writing Lewis dot structure, let us calculate first total number of valence electrons X. This is equal to 1 into 4 plus 1 into 6 plus 2 into 7. 4 valence electron for carbon, 6 valence electron for oxygen, and 7 valence electron for chlorine. This will be equal to 4 plus 6 plus 14. This is equal to 24. Number of electrons required for completing octet. Suppose it is Y. This will be equal to 1 into 8 for carbon plus 1 into 8 for oxygen plus 2 into 8 for chlorine. This will be equal to 8 plus 8 plus 16. This is equal to 32. Number of shared electrons. Shared electrons S. This will be equal to y minus x. This is equal to 32 minus 24. This is equal to 8. Number of unshared electrons. Unshared electron. This will be equal to x minus s. This is equal to 24 minus 8. This is equal to 16. Now on this basis, we shall draw the possible Lewis dot structures. Possible Lewis dot structures. First is, suppose O C Cl Cl. Number of shared electrons are how much? 8. 2, 4, 6, 8. The remaining electrons here 6, 8, 2, 4, 6. This is equal to 8. And for this oxygen, this will be equal to 2, 4, 8. So unshared electrons 2, 4, 6, 8, 10, 12, 14, 16. This carbon has completed its octet. So this is your C double bond O Cl. Suppose it is A and it is your Cl B, because there are two chlorine atoms. Unshared electrons 2, 4, 2, 4, 6, 2, 4, 6. Let us draw another Lewis dot structure. C O Cl Cl. So this is your 2, 2, 4, 6. You have to share 8 electrons. So this is your 2, 4. Okay. Now unshared electrons are how much? 16. 2, 4, 6, 8, 10, 12, 14, and 16. 8 electrons, 8 electrons, 8 electrons, and 8 electrons. The Lewis dot structure will be your C double bond O Cl 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 Cl. Let it is Cl A and it is your Cl B. Now let us draw another structure. O C Cl, 2, 4, 6, 8. Total number of electrons here 2, 4, 6, 8. This carbon has completed its octet. So 2, 4, 6, 8, 10, 12, 14, 16. Total number of unshared electrons. This will be your O, single bond C, double bond Cl, Cl, and this is your 2, 4, 6. Suppose it is your Cl A and it is your Cl B. So these are the three structures. Lewis dot structure for carbonyl chloride, which is also known as phosgene. And on the basis of formal chart, you have to decide that which of these Lewis dot structure will be the correct Lewis dot structure. And as I have told you, that will be the correct Lewis dot structure for the molecule or ion for which the formal charge on each atom is equal to 0. So let us calculate the formal charge in structure 1. In structure 1, formal charge on oxygen. On oxygen, this is your oxygen atom. Valence electron 6, minus unshared electrons are 4, minus shared electrons are 4. 1 by 2 into 4, this is equal to 0. Formal charge on carbon, CF on carbon. This is your carbon. Valence electron 4, minus unshared electron 0, minus shared electron 1 by 2 into shared electron 2, 4, 6, 8. So minus 1 by 2 into 8. This is also equal to 0. Formal charge on CLA. CF on CLA. This will be equal to valence electron 7 minus unshared electron 2, 4, 6 minus shared electrons 2. So this will be 1 by 2 into 2. This is equal to 0. CF on CLB 7 minus unshared electron 6 minus 1 by 2 into 2. This is equal to 0. So in this case, we find that formal charge on all the atoms is equal to 0. In structure 2nd, formal charge on carbon, oxygen. First we calculate on oxygen. CF on oxygen. This is your oxygen atom, 6 valence electron minus unshared electrons are 2 minus shared electrons 4 and 2, 6. So this will be 1 by 2 into 6. This is equal to plus 1. Formal charge on carbon. This is your carbon atom. Valence electron 4 minus unshared electrons 2 minus shared electrons 4. So this will be 1 by 2 into 4. This is equal to 0. Four minus 2 minus 1 by 2 into 4. CF on CL A. This is your CLA. Sorry, here in case of oxygen, Formal charge, those charge which is odd. This will be 8. 8. So this is equal to 0. X minus formal charge. Formal charge on CLA, this is equal to 7 minus, this will be equal to number of shared electrons, unshared electrons 6 minus number of, this is the wrong structure, sorry. This will be your C double bond or single bond Cl, and this will be Cl. So this is both the structures were same. Suppose it is CLA, CLB. Let's calculate again. C upon oxygen. C upon oxygen. This will be equal to valence electron 6 minus unshared 2, shared 3 bonds. So 1 by 2 into 6. This is equal to plus 1. CF on carbon. This will be equal to 4 minus unshared 2 minus shared 6. 1 by 2 into 6. So this will be equal to minus 1. CF on CLA. This will be equal to 7 minus unshared 6 minus shared 2, 1 by 2 into 2. This is equal to 0. Similarly, CF on CLB. This will also be equal to 7 minus 6 minus 1 by 2 into 2. This is equal to 0. So total CF is equal to plus 1 minus 1 plus 0 plus 0. This is equal to 0. So total CF here also equal to 0 plus 0 plus 0 plus 0 is equal to 0. Now in structure third, in structure third, CF on oxygen. CF on oxygen. This will be equal to 6 valence electrons minus unshared 6 minus shared 2, 1 by 2 into 2. So this is equal to minus 1. CF on carbon. This is our carbon. 4 minus unshared 0 minus 4 with shadow 8. 1 by 2 into 8. This will be equal to this is equal to 4 minus 4, 0. C upon CLA. This is your CLA. So this will be 7 minus unshared 4 minus shared 4, 1 by 2 into 4. This will be equal to plus 1. And C upon CLP. This is equal to 7 minus 6 minus 1 by 2 into 2. This is equal to 0. So total CF. This is equal to minus 1 plus 0 plus 1 plus 0. This is equal to 0. So we find that in all the cases total CF or total formal charge is 0. Therefore, all these values indicate that CoCl2 is a neutral molecule. But for structure first, we find that CF for all the atoms is equal to 0. And therefore, structure first will be the correct structure for the carbonyl chloride molecule. So we conclude that since CF for all the atoms in structure first is 0. So correct Lewis dot structure. Correct Lewis dot structure for CoCl2 is C double bond O Cl Cl thus with the help of CF value, that is the formal charge value, we can predict that which will be the Lewis dot, which will be the correct Lewis dot structure for a molecule or ion.